Good day, everyone. We are the Group 3, and today we will be discussing about the aggregate planning in the supply chain. And by the way, I am Jayward Balinas, and joining me are my teammates Lloyd Lubete, Jenny Ann Madeja, Iris Joy Mercado, and Jane Carlinases. So, by the end of this presentation, we aim to cover a few key learning objectives. So, first, we will understand the vital role aggregate planning plays as a supply chain activity. Then, the data required to build these plans and basic trade-offs manager must consider. And then, finally, we will show you how to formulate and solve these complex operational problems using Microsoft Excel.
The aggregate planning problem. So, planning how a company balances supply and demand, focuses on production, workforce, and inventory. Goal is to meet customer demand at the lowest cost. So, yung aggregate planning problem is about sa kung paano nagpa-plan ang isang company para mabalance yung supply at demand. So, dito nagbe-base kung gaano karami yung ipoproduce na product, kung ilang workers yung kailangan, at kung gaano karaming inventory ang i-store. Usually, ginagawa ito for a few months ahead. Ang goal talaga is ma-meet yung demand and customers habang minimize yung cost. So next is yung objective of aggregate planning. So ang main objective ng aggregate planning is to satisfy customers' demand while maximizing profit ng company. So ibig sabihin lang, basta makapag-produce, kundi dapat ginagawa ito in a way na kumikita pa din yung business. Next is objective of aggregate planning. Ang goal is to satisfy demand while maximizing profit. Determine for each period, production level, inventory level, capacity, and backlog. So, ang main objective ng aggregate planning is to satisfy customer demand while maximizing the profit ng company. So, ibig sabihin, hindi lang basta makapag-produce, kundi dapat ginagawa ito in a way na kumikita pa rin yung business. So, for each time period, kailangan nilang mag-decide kung gaano karami yung ipoproduce, gaano karaming inventory yung i-stock, gaano kalaki yung capacity, whether internal or outsourced, at kung may demand na hindi agad ma-meet na tinatawag na backlog. For example, imagine natin na yung isang clothing company, kapag mataas yung demand sa December dahil sa Christmas season, pwede silang mag-produce ng mas marami before December, kaya mag-store ng inventory, o kaya mag-hire ng temporary workers, or mag-outsource, or kulang talaga, or kung kulang talaga, may ibang orders na madedelay or yung backlogs. So, lahat ng desisyon na ito, iginagawa nila para ma-meet yung demand. Pero at the same time, ma-maximize nila yung profit at may iwasan nila yung unnecessary cost. Next is planning horizon and aggregate planning. So, bago makagawa ng aggregate plan, kailangan mo nang i-define ng company yung tinatawag na planning horizon. O ito yung time period kung saan nila gagawin yung plan. Usually around 3 to 8 months yung time frame. So, hinahati din nila yung time na ito into smaller periods tulad ng per weeks, months, or quarters para mas madaling i-track at i-manage yung production at yung demand. So, after that, nag-collect sila ng important information like demand forecast, available workers, materials, and production capacity. So, ito yung magiging base nila sa paggawa ng plan. For example, isipin natin yung isang company na gumagawa ng bottled water. Kung alam nila na mas mataas ang demand during summer months, gagawa sila ng plan for the next 6 months. Pwedeng mag-produce sila ng mas maraming product bago mag-summer para ready sila sa mataas na demand. So basically, yung planning horizon, it helps the company to prepare ahead para hindi sila maubusan ng stock at hindi rin sila mag-overproduce. Aggregate planners requires, first, we have the aggregate demand forecast which is represented by F in small t. Ibig sabihin ito yung expected demand natin for each period like per month or per quarter. And take note, this forecast extends over time periods. So meaning, hindi lang siya isang time. Tuloy-tuloy siya across a planning horizon. So, parang tinitignan natin yung demand over time, hindi lang in one point. Next, we have production cost. Importante to kasi dito nakabase kung magkano yung magiging total expenses natin. Una, yung labor cost. May dalawa itong type, yung regular time which is normal working hours and overtime na usually mas mahal. So, kailangan natin mag-decide kung kailan worth it mag-overtime. Second, we have the cost of subcontracting. Ito naman yung situation na hindi na kaya ng sariling production capacity natin. So, nag-outsource na tayo dito. Pero syempre, may additional cost to. Either per unit or per hour tayo. And lastly, underproduction cost. We also consider the cost of changing capacity. Ibig sabihin, kung mag-hire tayo ng bagong workers or magle-lay off, may cost yon. Same din if magdadagdag or magbabawas tayo ng machine. Hindi siya free, so kailangan din siyang i-factor in. Next is labors and machine. So, kailangan din natin malaman kung ilang hours ang kailangan per unit. For example, kung 2 oras per product, madali natin makukompute kung ilan yung kayang gawin ng workforce natin. Kung sobra naman yung production natin, mapupunta siya sa inventory. Pero hindi siya free, may storage cost, maintenance at risk pa pag ito'y nasira. So, kaya hindi rin okay na sobrang dami ng stock. Kapag kulang naman yung production, magkakaroon ng stock out. Ibig sabihin, hindi natin ma-serve yung customer on time. Pwede itong mag-lead sa lost sales or bad customer experience. Hindi rin tayo free gawin lahat. May mga constraint like limit sa overtime, budget hiring, at kahit sa suppliers. So, kailangan realistic yung plano natin. So, overall, kailangan natin i-consider yung demand, cost, capacity, at constraint dahil lahat yan ay kailangan balance para efficient at mas cost-effective yung production. Next is aggregate planning. So, dito naman sa production quantity, tinitignan ng company kung gaano karami yung kailangan nilang i-produce. So, may 3 main options sila. Regular time, overtime, at subcontracting. So, sa regular time means normal working hours lang. Kapag tumaas ang demand, pwede silang mag-overtime para madagdagan ng output. If hindi pa rin sapat yun, pwede silang mag-subcontract. Meaning, ipapagawa nila sa ibang company yung production or mag-outsource sila. So, this decision affect not just output but also cost, workers, and suppliers' orders. So, sa inventory health naman, ito naman yung tungkol sa mga products na nakastock lang muna sa warehouse. Importante ito kasi habang mas maraming inventory, mas maraming space yung kailangan at mas maraming pera yung naka-invest sa goods na hindi pa nabibenta. So, kung sobra yung inventory, nagiging costly siya. Pero, kung kulang naman, baka hindi natin ma-meet yung demand ng customer. Kaya, kailangan talaga ng tamang balance para hindi sayang yung resources. Next naman is backlog and stock out. Ang backlog, ibig sabihin ang customers pero hindi pa agad mapufulfill. So, delayed siya. So, ang stock out naman is mas serious. Ibig sabihin, wala talagang available na product. So, possible mawalan ka ng sales. Both cases can negatively affect customer satisfaction kasi ayaw ng customers ng delay or unavailable product. So, companies try to minimize this situation as much as possible. Next is workforce changes. So, sa workforce naman, yung company pwede mag-decide kung kailangan ba nilang mag-hire ng additional workers or kung mag-lay off ba sila ng mga employees. Kapag mataas yung demand, usually, nag-hire sila. Pag mababa naman, posibleng magbawas ng workers para mabawasan yung cost. Pero hindi lang cost ang factor dito. May affect din to syempre sa employee morale, training cost, at overall stability ng workforce. So, kailangan pag-isipan ng mabuti. And next is machine capacity. So, it refers kung gaano karaming production ang kayang i-handle ng equipment. Kung mataas ang demand, baka kailangan bumili ng bagong machines or mag-expand ng capacity. Pero kung bababa naman yung demand is, pwedeng hindi mo na gamitin yung ibang equipment. So, this decision is important kasi malaking investment yung machine. And ayaw ng company na masayang lang sila. This is identifying aggregate units of production. Choose a common unit of measurement, reflect actual production capability, focus on bottleneck, consider non-productive activities. So, bago pa magsimula yung actual aggregate plan, may very important first step is kailangan muna natin i-identify kung ano yung aggregate unit of production. So, ano bang ibig sabihin nito? Basically, ito yung gagamitin mong common unit para masukat ang production. For example, pwedeng number of units, labor of hours, or kahit weighted average ng different product. Especially kung iba-iba yung products na ginagawa ng company. Importante rin na tama yung unit na PPN kasi dapat nire-reflect nito yung actual capability ng production system. Ibig sabihin, dapat realistic siya at align sa kung ano talaga yung kayang gawin ng company in real life, hindi lang sa theory. So, another key point is yung bottleneck. Ito yung part ng production process na pinaka naglilimit ng output. Halimbawa, kung may isang machine na mabagal compared sa iba, siya yung bottleneck. So, kapag pumipili ka ng aggregate unit, dapat nakapokus ka sa bottleneck. Kasi siya talaga ang magdidictate kung gaano karami ang kaya mong i-produce. Also, kailangan din i-consider yung mga activities na kakain ng time. Hindi directly nagpo-produce ng output like setup time, maintenance, or machine downtime. Kasi kung hindi mo sila isasama sa plan, magmumukhang mas mataas yung capacity mo kaysa sa actual. And that can lead to unrealistic plans na hindi naman kayang i-implement. So in short, choosing the right aggregate unit is very important para mas maging accurate, realistic at workable yung buong aggregate plan mo. Ito naman yung example ng Red Tomato Tools. Ito yung table niya. So to better understand aggregate planning, let's look at an example. So isa itong example ng manufacturing company na gumagawa ng gardening equipment and meron silang production facility sa Mexico. So, instead of focusing sa individual products, hinati nila yung items into 6 product families, labeled A to F. Ginagawa to para mas mapadali yung planning process kasi instead na isa-isahin yung bawat product, mas madali kapag nakagroup sila. So now, for each product family, meron silang data tulad ng material cost per unit, revenue per unit, setup time, production time, average batch size, and percentage share ng sales. So, lahat ng information na to is very important kasi ginagamit siya para ma-analyze kung alin sa product ang mas profitable, kung ano yung mas time consuming, at kung saan dapat mag-focus yung production planning. So, isa sa pinaka-importanting concept dito is yung production time per unit. Hindi lang kasi production time yung tinitignan. Kailangan din i-consider yung setup time. So, ano yung setup time? Ito yung time spent preparing machines bago magsimula ang production. Hindi siya directly nagpo-produce ng output pero necessary siya. So, para maging fair ang measurement, hinahati yung setup time based sa batch size. For example, kung 8 hours ang setup time at 50 units, ang batch size, bawat unit, magkakaroon ng small share ng setup time. Then, ina-add siya sa actual production time para makuha yung production time. So, this gives a more accurate picture kung gaano talaga katagal gawin yung isang unit. So, bakit ba importante yung table na to? Una is nakakatulong siya para ma-identify kung alin sa product ang kumakain ng pinakamaraming time na possible na mag-bottleneck. So, pangalawa, makikita mo kung alin yung mas profitable versus mas resource intensive. Di porket mataas revenue, ibig sabihin efficient na siya gawin. Third is, this data helps create realistic aggregate plan. Kasi kung hindi mo isasama yung setup time or actual production time, magiging inaccurate yung planning mo. And lastly, ginagamit ito for decision making. Like, kung alin yung dapat i-prioritize, kung saan mag-i-invest, or kung saan magbabawas ng production. So this example shows how detailed data helps improve to the accuracy and effectiveness ng aggregate planning.
Let's talk about the aggregate planning strategies. So, aggregate planning has a goal of finding its most profitable combination of trade-offs to meet the customer demand because demand changes over time. So, for example, in bakery, there are months that are much busier than the regular months, such as Christmas, Valentine's Day, Mother's Day, and so on. So, planners have to balance three main costs, or also called as the levers. So the levers are the capacity, inventory, and backlogs. So the capacity is the ability of a business to produce. So this includes regular labor, overtime, or hiring subcontractors. And then we have inventory. So this is the stock that the business keeps to use later. And then we have backlogs. So this is when the business asks the customers to wait for their delivery because they cannot fulfill it immediately. We have three main aggregate planning strategies that the planner uses to achieve balance among the three costs. And the first one is the chase strategy, using capacity as the lever. So this kind of strategy matches the production to customer demand. If the demand goes up, you hire more people or run more machines. If the demand goes down, you fire people or shut the machines down. So this is good in having low inventory, but this is expensive because of constant hiring, training, and equipment changes. It also ruins employee morale because they never know if they still have a job next week or next month. So this is best used when you are storing expensive items but easy to find extra workers. Second is the flexibility strategy, using utilization as the lever. So this kind of strategy keeps the same team of people, but you change how many hours they work. So when things gets busy, they work overtime. When things get slow, they work fewer hours. So you don't have to fire anyone when demand drops, which keep the team much happier than the chase strategy. This is also good in having low inventory, but the utilization is also low. So it is best used when inventory carrying costs are high and machine capacity is relatively inexpensive. Third, we have the level strategy, using inventory as the lever. So this kind of strategy keeps everything constant. You have the same number of workers, the same number of hours, and the same machine speed every single day, regardless whether the sales are high or low. So this keeps the workforce happy, but this can also lead to backlogs and customer delay if the business runs out of stored stocks. This can also lead to storage costs because the business might have a high inventory. So it is best used when it is cheap to store items for a long time, such as canned goods, and you want to keep your production costs low and steady. Additionally, we also have a so-called hybrid or tailored strategy that most businesses use. So for example, a bakery might keep a steady staff but use a little bit of overtime during the busiest week of the year.
So let's proceed to aggregate planning at Red Tomato Tools. So Red Tomato Tools sells gardening equipment, which means business is highly seasonal. Demand peaks only in the spring when everyone starts planting and drops off significantly in the winter. So the company forecast shows a surge from 1,600 in January, February 3,000, March 3,200, April 3,800, May 2,200, and in June again 2,200. So the core problem for any management is how do they can meet this fluctuating demands or fluctuating peaks without spending a large cost or a large fortune. So to handle this problem, the options for Red Tomato is adding workers during the peak season, subcontracting out some of the work, building up inventory during the slow months, or building up a backlog of orders that will be delivered late to customers. So for this next table, this shows the cost for Red Tomato. It shows the item and the cost for material cost, inventory holding cost, marginal cost of stock out, hiring cost, layoff cost, labor hours required, regular time cost, overtime cost, and cost of subcontracting. So to build a plan, the company have to understand the limits. Each worker is available for 20 days per month and 8 hours per day. Since the product takes 4 hours of labor to make, a single worker can produce exactly 40 units per month. So knowing this allows the company to calculate how many people they need to hire or how much overtime is required to meet the numbers of their forecast. So the decision that the company make has a price or has a cost. So the goal isn't just to make tools, it's also to make them at the lowest possible cost. So the hiring and laying off costs $300 to hire and train a worker, but $500 to lay one off. So for the storage, Keeping a tool in the warehouse costs $2 per month, and for the stock outs, if the company fails to deliver on time, it costs $5 per unit, and for the subcontracting, $30 per unit, which is the most expensive option. So because the company has shown that they will eventually meet all demand and the selling prices fixed, maximizing the profit is the same thing as minimizing the total cost. So the optimal plan is the specific combination of hiring, overtime, and inventory that lets the company survive the April peak and end the 6-month period in June with a healthy safety stock of 500 units, all while keeping expenses as low as possible.
Aggregate planning using linear programming. The goal of aggregate planning is to maximize profit while meeting demand. A highly effective tool for a company to use when it tries to maximize profits while being subjected to a series of constraints is linear programming. So linear programming finds the solution that creates the highest profit while satisfying the constraints that the company faces. Here are the decision variables that needs to be met when using the linear programming. First, we have the workforce size for the month denoted by capital W sub D. Next is the number of employees hired at the beginning of the month denoted by H sub D, and the number of employees laid off at the beginning of the month denoted by L sub T. And then we also have the units produced in a month denoted by P sub T. We have the inventory at the end of the month, it is denoted by I sub T, and we have the number of units stock out or the backlogs at the end of the month denoted by S sub T. And we also have the units of subcontracted for the month denoted by C sub T. And lastly, we have the number of overtime hours worked in a month denoted by O sub T. So what is the objective function when we use linear programming? The objective function is to minimize the total incurred cost over the planning horizon. And here are the list of the total cost. First, we have the regular time labor cost, which is the cost of the workforce during the standard hours. And then next, we have the overtime labor cost. It is the additional cost for extra hours worked by the employee. Next, we have the cost of hiring and layoffs. It is the expenses related to changing the workforce size. Next, we have inventory holding cost. It is the cost to store product from one period to the next period. And next, we have the cost of stocking out. It is the cost associated with failing to meet customer demand on time. And then we have here the cost of subcontracting. It is the cost for outsourced production. And then lastly, we have the material cost, which is the cost of raw materials. So of course, we're using the linear programming. There is a constraints that we called, and the constraints that we have here is first the workforce, hiring, and layoff constraint. So it is the workforce size that is denoted by capital W sub T in a period. It is obtained by adding the number of hired people in the period to the current workforce that they have in a period, and we subtract it to the number of laid off or those employees who resigned. So the formula that we have here is W sub T equals W sub T minus 1 plus H sub T minus L sub 1. Next, we have the capacity constraints. So in each period, the amount produced cannot exceed the available capacity. So this set of constraints limits the total production by the total internally available capacity. So how do we get the capacity constraints? We have here the formula. P sub T is less than or equal 40 W sub T plus O sub T over 4. So the 40 there is the number of units that an employee can produce for Red Tomato Company. And then next we have the inventory balance constraints. So the third set of constraints balance inventory at the end of each period. Net demand for a period is obtained as the sum of the current demand and the previous backlogs. This demand is either filled from current production or subcontracted production and previously inventory. So we can solve that relationship using the following equation. We have here the I sub d minus 1 plus P sub d plus C sub d equals D sub d plus S sub d minus 1 plus I sub d minus S sub d. And lastly, for constraints, we have the overtime limit constraints. This is the fourth set of constraints that requires no employee work more than 10 hours of overtime each month. These requirements limits the total amount of overtime hours available as follows. So we have here the equation. O sub t is less than or equal to 10 W sub d. So the 10 there is the hours that an employee should not exceed. So for example, number one, we have here the table 8.4. So Red Tomatoes lays off a total of 16 employees at the beginning of January. After that, the company maintains the workforce and production level. It uses subcontractor during the month of April. You can see here the 140 value. And Red Tomato carries a backlog only from April to May. In all their months, it plans no stackouts. In fact, it also carries inventory in all period, and we describe it as the seasonal inventory because it carried in anticipation of future increase of demand. So this table basically describe that the Red Tomato was able to anticipate the future demand. So what will happen if the demand suddenly grows or fluctuate? If the seasonal fluctuations of demand grows, synchronizations of supply and demand becomes more difficult, resulting in an increase in either inventory or backlogs, as well as increase in total cost of the supply chain. Here in the example, table 8.5, we can see that the demand suddenly fluctuate, so the monthly production remains the same, but both the inventory and the stock out backlogs went up. On the next example, we can see the impact of lowering the cost of hiring and layoffs. So increasing volume flexibilities by decreasing the cost of hiring and layoff not only decreases the total cost but also shift the optimal balance toward using the volume flexibility while carrying lower inventories and allowing less stackouts.
Once we understand the theory and the mathematical models, we need to transition into practical applications. This brings us to aggregate planning using Excel. When handling complex logistics and operations research problems, the first thing we do is build a simple spreadsheet. This basic setup allows us to conduct what if analysis to see how different decisions impact our supply chain. Once that baseline is established, we can build a much more sophisticated model that utilizes linear programming to optimize our plans. Now, let's look at how we construct that initial baseline. Building a basic aggregate planning spreadsheet requires us to define our decision variables clearly. For a given time period, usually a month, we track specific metrics. We set off columns for our workforce size, W sub T, the number of employees hired, H sub T or laid off L sub T, and the total units produced P sub T, and the inventory remaining at the end of the month I sub T. We also track operational factors like subcontracted units, stock outs, and overtime hours. The power of the spreadsheets comes from the formulas linking these variables. For instance, our formula for current inventory relies on adding our previous inventory to our total production and subcontracting and then subtracting the current demand. This creates a dynamic system where changing our input updates the entire operational timeline. Moving on, tracking data is good, but optimizing it is the ultimate goal. This is where we move to building an aggregate planning spreadsheet using Solver. So, using the linear programming capabilities within the Excel solver, our primary objective is to minimize the total cost to maximize profit. So we set our target cell to calculate the total cost, which sums up regular and overtime labor, hiring and layoffs, inventory holding, and any subcontracting or stock out penalties. Before we can optimize, we must input our constraints. We program solver to respect our limit on workforce capacity, required inventory balances, and maximum allowable overtime. So by running the solver tool, Excel automatically adjusts our decision variables to find the most cost-effective production schedule that satisfy all of our constraints. Finally, we must address the reality of the supply chain forecasts are always inaccurate. To improve the real-world quality of our aggregate plans, forecasting errors must be considered from the very beginning. We deal with these inevitable errors by building buffers into our models, specifically through safety inventory or safety capacity. Depending on our overall strategy, a company might buffer against demand spikes by using overtime, permanently carrying of extra workforce, or utilizing subcontractors. Alternatively, they might choose to build and carry extra seasonal inventories. The key is the plan must be flexible enough to adapt when actual demand deviates from our forecast.
Next is building a rough master production schedule. A master production schedule or MPS is developed from an aggregate plan. It breaks down total production into specific time periods, individual product families. It determines how much to produce, when production should happen. It serves as a link between planning and actual productions. Helps ensures that production plans are realistic and organized. So, yung Master Production Schedule or yung MPS is galing sa Aggregate Plan, which is more general. So, ang ginagawa natin dito is binibigyan natin siya ng mas detailed breakdown. Hinahati natin yung production per time period at per product family. Dito na natin makikita kung gaano karami yung ipoproduce at kung kailan siya gagawin. So, ang importante dito is siya kasi yung bridge between planning at actual production. Meaning, dito naging actionable yung plan. Next is simple disaggregation approach. So, sa approach na to, ginagamit natin yung simple disaggregation. So, ibig sabihin, hinahati natin yung total production into different product families based sa demand. Tapos, kinukompute natin kung ilang batches or setups yung kailangan. Maganda siya kasi simple lang. Hindi siya complicated at mabilis lang siyang gawin. Pero syempre, meron pa rin mga limitations. Hindi siya pinaka-accurate at minsan hindi niya nakukonsider lahat ng real-world factors like unexpected delays or constraints. So here's the advantages and the limitation. First is simple and easy to implement. Requires minimal data and computation. Allows quick feasibility checking. And for limitations naman, not necessarily optimal, may oversimplify real-world conditions, and last, does not capture all operational constraints. Next is the feasibility and key insights. So, feasibility is checked by comparing required production time, available production capacity. More advanced methods exist, more complex and harder to implement, may still not fully reflect real situation. So, after natin i-breakdown yung plan, so, chine-check naman natin kung feasible siya. So, ibig sabihin, kinukumpara natin yung required production time sa available capacity. May mas advanced method naman, pero mas complicated nga lang sila gamitin. Kaya sa real world, ang madalas na ginagamit pa rin ay yung simple approach kasi practical siya at mabilis magbigay ng decision. So, in the end, ang goal natin is makagawa ng plan na realistic at kayang ma-execute. So, this is disaggregating the aggregate plan at Red Tomato Tools for period 1. So, here's the table. So, dito naman sa table, makikita natin kung paano na-disaggregate yung aggregate plan into different product families for period 1. So, we have 6 families, A hanggang F. So, unahin natin si family A. Makikita natin na yung setup time niya is 8 hours per batch. And the average batch size is 50 units. Yung production time per unit is 5.6 hours. And ang total production quantity niya is 256 units. So ngayon, para malaman kung ilang setups yung kailangan. So, dinivide natin yung 256 by 50. And lumabas siya around mga around 5. So, we round it down into 5 setups. So, overall, yung setup time niya is 40 hours. And yung production time is 1,433.6 hours. Same process lang ginagawa natin for the other families. For example, si Family B, mas malaki yung batch size niya, which is 150 units. Kaya mas konti lang yung setups niya, which is 4. Pero kahit ganun, mataas pa rin yung production time niya. Because mas marami siyang total quantity, which is 640 units. Then, for families C, D, E, and F, mapapansin natin na karamihan nasa around 5 setups din. Pero, nagkakaiba-iba sila sa production time depending sa batch size, sa production time per unit, and sa total quantity. So, basically, kahit pare-pareho yung number of setups ng iba, hindi pareho yung total production time nila. Now, kapag inad natin lahat ng setup time and production time across all families, makukuha natin yung total required time for production. And this is important kasi dito natin malalaman kung feasible ba yung plan based sa available capacity. So, in short, this table shows kung paano natin hinati yung production, ilang sets up yung kailangan, at kung gaano katagal gawin yung bawat product family.
Now let's move forward to the role of IT in aggregate planning. So aggregate planning was one of the most technology-supported areas in supply chain. Early systems only checked if a production was possible based on demand and capacity. But modern systems now choose the best plan by minimizing the cost or maximizing the output, usually using linear programming. Today, companies use advanced planning systems from providers like SAP and Oracle to create these plans. However, one challenge is that small changes in data, like demand, can result in a very different plans, making them unstable and hard to trust. Lastly, accurate data is very important because incorrect inputs can lead to poor decisions, higher costs, and unhappy customers.
For implementing aggregate planning practice, first we have think beyond the enterprise. So first we have to think beyond our own company walls. Most managers make the mistake of only looking at their internal data, but your business is just one link in a larger chain. So if your suppliers are struggling or your distributors are overwhelmed, your plan will may fail. Your plan may fail. So you have to work with your upstream and downstream partners. Share your forecast and talk about their constraints. You have to remember that your aggregate plan is only as good as the quality of the data you get from the entire supply chain. Number two is build in flexibility. Next, we have to face the hard truth that forecast might be wrong. So if you build a rigid plan based on a 100% accurate forecast, you're setting yourself up for a disaster. So we need flexibility. One way we do this is through sensitivity analysis. So before committing to a big decisions like expanding a warehouse, you have to ask yourself if what happens if your demand or if the demand is inaccurate. So if a small drop in demand causes a massive spike in cost, it might be better to postpone the expansion. So you have to always choose the solution that works best across a wide range of possibilities. Number three, rerun the aggregate plan as new data emerge. So while these plans usually over a horizon of 3 to 18 months, you shouldn't wait a year to look at it again. As new data emerge, like a sudden shift in market trends, you need to rerun the plan. However, there's a catch. So you have to be careful, or a manager have to be careful not to change things too often. You want to stay updated without creating plan volatility. So that confuses your production team. So you have to use the latest values to tweak the map, not redraw it every single day. Number four, and lastly, you have to use planning as capacity fills up. So when a company is only at 50% capacity, they can usually wing it just by following incoming orders. But as you get closer to 100%, there is no room for error. So when utilization is high, relying solely on orders leads to shortage and delays. So this is where aggregate planning serves the day. So it helps you manage your limited resources effectively so you can meet demand without breaking the system. So to wrap up our discussion on Chapter 8, we have here the summary. Understand the importance of aggregate planning as a supply chain activity. Describe the information needed to produce an aggregate plan and the outputs obtained, explain the basic trade-offs to consider when creating an aggregate plan, and explain the basic trade-offs to consider when creating an aggregate plan.